The beekeeping industry is in crisis over the shocking and unexplained deaths of hundreds of millions of bees over the last 8 months.
They thought it was impossible for anything to wipe out an entire nation's bees. They believed Australia was untouchable, protected by oceans, tight borders, and decades of strict quarantine. Then a silent killer crossed the threshold.
It's going to have a huge impact on the feral bee colonies. They're talking 90 to 95% death.
Within months, hives collapsed. Fields went quiet, and farms fell into panic. What destroyed bees in other countries had finally reached the last safe place on Earth.
And so the infected area at the moment has been cordoned off, and there is a movement put in place, which means that no beehives.
No one knew how bad it would get. Then 1 year later, something truly shocking happened. The global bee apocalypse. The world began to collapse long before Australia faced any threat. A deadly force had already swept through the United States, Europe, China, and South America. It destroyed bees everywhere it appeared, and no country found a way to stop it. The crisis did not look dramatic at first. It started with small drops in bee numbers that were easy to ignore. Over time, those drops turned into mass disappearance. Entire regions watched their honeybees vanish and discovered that their food system depended on creatures that were now dying in silence. At the center of this disaster was a parasite called the varroa mite. It was small enough to hide in the folds of a bee's body. It crawled into hives and fed on adult bees and young bees. It weakened their bodies by draining the organs that controlled immunity. These organs worked like the bee's liver. Without them, the bees slowly lost all strength. The parasite also spread dangerous viruses that caused twisted wings and shaking legs. Bees that looked healthy 1 week could collapse the next. Varroa created a wave of destruction everywhere it arrived. It moved from hive to hive through drifting bees, shared equipment, and natural movement across landscapes. No country that encountered it remained the same afterward. In the United States, the situation reached terrifying levels. Some winters ended with nearly 40% of all colonies dead. This meant that almost half of the bee population did not make it to spring. Farmers who depended on bees for pollination had to rent hives from beekeepers at very high prices. Almond growers warned that a failed bee season meant a failed crop. They said that renting bees now cost more than hiring farm workers. The country began to understand that its food supply depended on a creature it could no longer protect. China saw a different but equally frightening outcome. In some regions, every honeybee disappeared. Orchards became silent. Blossoms opened and wilted without producing fruit. Farmers had to climb trees and use small brushes to move pollen by hand. This process was slow and exhausting. It reminded many experts of desperate methods used during historical famines. People were trying to replace a natural system that had supported them for thousands of years. Everyone involved knew that this was not a real solution. Europe faced a collapse made worse by chemicals, extreme weather, and loss of wild habitats. Many farms looked normal on the surface, but were empty of insects. Scientists compared the site to the strange emptiness seen after the Chernobyl event. Fields that once swarmed with bees now felt dead. Fruit yields dropped. Pollination windows shortened. Farmers feared the coming season every year because they no longer trusted the land to support life. Scientists warned that global food security was at risk. They explained that the situation reminded them of the Irish potato famine. That disaster began in the 1840s when a plant disease destroyed almost the entire potato crop in Ireland. Most families depended on potatoes as their main source of food, and when the crop failed for several years in a row, more than 1 million people died and another million were forced to flee the country. The famine showed how fast a nation collapses when one essential food source is wiped out. Researchers said the bee crisis was even more dangerous because it did not threaten only one crop. It threatened almost every fruit and vegetable that depended on pollination, which meant the scale of damage could be far worse than what happened in Ireland. As all these went on, only one region remained untouched by the parasite. Australia held out while the rest of the world fell, but even the strongest fortress eventually faced the danger everyone else fears. Australia was the last fortress. For years, experts believed that Australia stood alone as the only continent strong enough to keep the global bee crisis from reaching its borders. The country's strict isolation and heavy quarantine system created a sense of safety that the rest of the world had already lost. This protection came from a long history of dealing with invasive pests. Australia is surrounded by ocean, which makes it harder for foreign insects to enter. The government also enforced strict biosecurity rules at airports, shipping ports, and farms. Travelers could not bring honey, pollen, or used beekeeping equipment. Cargo shipments went through careful inspections. Farms faced serious penalties if they moved hives without approval. These measures were designed to stop any parasite that could harm Australia's agriculture. Because of this system, the country remained free from many diseases that had already destroyed bee populations in other regions. Australians trusted this system completely. That trust collapsed in June 2022. At Newcastle Port, inspectors began a routine check on honeybee monitoring stations. These stations were placed there to detect any sign of foreign parasites. During the inspection, the team noticed tiny red particles on the monitors. At first, the particles looked like harmless dust. When the inspectors used magnification tools, they discovered the truth. The red particles were moving. They were alive. They were Varroa destructor mites, known worldwide as the deadliest parasite ever recorded in honeybee history. This discovery felt like a historical turning point. Some experts compared the moment to when Yersinia pestis, the bacterium that caused the Black Death, first appeared in Europe. One infected ship arrived at a European port and brought a disease that spread through towns and villages with extreme speed. Trade routes collapsed. Governments lost control because the disease moved faster than they could contain it. Millions of people died, and the structure of European society changed forever. Experts explained that the arrival of Varroa in Australia carried the same kind of threat. One contaminated hive had the power to spread the parasite from state to state. It could damage food production, weaken farms, and force Australia to rebuild its entire pollination system. Newcastle is one of the worst possible entry points. It handles over 4,000 international ship arrivals every year. This meant thousands of opportunities for the parasite to slip in. The moment authorities confirmed the presence of Varroa destructor, the country entered a state of shock. Many people understood that the arrival of this parasite meant the end of Australia's unique safety. It meant that the same collapse that destroyed bee populations across the United States, Europe, and China might soon unfold on Australian soil. Government officials responded with extreme speed. They ordered immediate lockdowns in surrounding regions. These lockdowns froze 300,000 commercial hives in place. No beekeeper was allowed to move their colonies. No trucks were allowed to transport bees for pollination. The entire system that connected bees to food production stopped overnight. Farmers who depended on these hives watched their plans collapse within hours. For the first time, Australia saw a type of emergency that looked similar to the severe agricultural controls used during the foot and mouth disease outbreaks in the United Kingdom. Roads and farmland regions were placed under strict control. Police officers and agricultural inspectors worked together to seal highways and rural areas. They set up checkpoints where vehicles were stopped and inspected for any sign of bee movement. Some areas had biological scanning devices to detect contamination. These scenes were unlike anything farmers had ever experienced in Australia. The nation understood that a new and dangerous chapter had begun. But what terrified officials most was not how fast Varroa spread. It was the horrifying way it killed bees once it entered a hive. How Varroa killed bees in ways more terrifying than anyone predicted. Varroa mites did not kill bees with one fast strike. They killed them slowly and painfully. They attach themselves to the bee's body and feed on the bee's fat bodies. Fat bodies are the organs that control immunity and help bees fight infection. When the parasite drained these organs, the bee would lose all strength. It is similar to a human losing their liver piece by piece while still trying to live. The bees became weak and unable to protect themselves from disease. The situation grows far worse inside the brood cells where young bees develop. When the queen lays an egg and the worker bees seal the cell with wax, the cell is meant to be a safe place for the larva to grow. Varroa mites use this moment to crawl inside the cell and feed on the developing bee. As the larvae grow, the parasite feeds on its organs. The larva often turns into a soft and sunken body that looks similar to rotting tissue. Many brood chambers are filled with dying young bees that never reach adulthood. The smell and appearance shock anyone who opens the hive. The mites also carry dangerous viruses that create even more destruction. One of the worst viruses causes deformed wings. Newborn bees crawl out of their cells with twisted wings that look crushed or crumpled. They cannot fly or walk properly. Their legs shake uncontrollably. They die shortly after emerging. Experts compare the damage to the severe birth defects created by medical disasters in the past. The sight is disturbing and unforgettable. It shows how completely helpless the bees have become. Entire colonies collapsed in a matter of hours once the infection grew strong enough. Beekeepers who checked their hives in the morning sometimes returned later that day to find complete silence. The sound of thousands of bees working together had disappeared. When the lid was lifted, there were piles of dead bees stacked across the bottom boards. These piles looked like miniature mass graves. Mites were often still crawling on the bodies. Some hives died so quickly that the honey frames were full and untouched. There were no bees left to use the food. These hives were called ghost hives. They were similar to abandoned towns left empty after deadly epidemics. Scientists began comparing varroa to some of the most destructive diseases in human history. Varroa spread through bee populations by weakening the immune system in a way that reminded researchers of HIV. Colonies died as completely as indigenous communities struck by smallpox. The movement of infected bees across landscapes reminded experts of locust swarms that consumed everything in their path. Australia soon saw the first visible signs of colony collapse. Dead bees covered the ground near hive entrances. The small bodies looked like ash scattered across the dirt. It was clear that the threat inside the hives was now reaching the surface for everyone to see. Terrified, Australia launched the most aggressive war in its agricultural history. It quickly became clear that this was a war they could not win. Chemicals, hive burnings, and agricultural collapse. The discovery of varroa at Newcastle triggered one of the most aggressive agricultural responses in Australian history. Authorities believed that the only way to stop the parasite was to destroy everything it touched. They declared a biosecurity emergency and ordered full eradication of any hive found inside the infected zones. This decision brought fear and anger across the beekeeping community. Teams of inspectors arrived at apiaries with protective suits and fuel containers. Entire apiaries were burned in open fields. Thick smoke rose above farmland as thousands of colonies were destroyed in a single day. By the end of the first months, more than 14,000 hives were burned. Many beekeepers said the scenes reminded them of the mass livestock burnings during the foot and mouth disease crisis in the United Kingdom in 2001. The goal was to kill the parasite before it spread, but the destruction also killed healthy bees and wiped out years of beekeeping work. As the burnings continued, authorities turned to chemical warfare. They approved emergency use of fipronil in infected areas. Fipronil is a pesticide known for its extreme toxicity. Scientists warn that only a few parts per billion in water can kill entire river ecosystems. The government used it as a weapon against varroa by spreading it inside quarantine zones. Many ecologists said this choice was similar to using napalm to stop a small fire. The pesticide did kill mites, but it also posed a severe risk to native insects, aquatic life, and soil organisms. The heavy chemical use created fear that Australia could lose far more than honeybees. Despite the aggressive burnings and chemical operations, the parasite continued to spread. Illegal hive movements made the situation worse. Some beekeepers, terrified of losing their entire livelihood, secretly moved hives out of quarantine zones at night. They hoped to protect their bees from destruction orders. These actions spread the parasite even faster. Hidden hive relocations turned containment zones into biological minefields. A few infected hives placed in new regions allowed varroa to travel hundreds of kilometers without detection. Inspections across New South Wales showed that varroa had moved far beyond the original outbreak site. Within a few months, nearly 300 outbreak locations were confirmed. The speed of the spread shocked scientists. It followed a pattern similar to the first year of the COVID-19 outbreak, where early containment failed because movement across regions happened faster than authorities expected. It became clear that destroying hives and flooding fields with chemicals could not stop a parasite that moved silently inside sealed brood cells. While the eradication effort failed, Australia's food system began to break apart. Almond orchards missed critical pollination windows because hive movements were restricted. Farmers watched healthy blossoms drop without forming nuts. Fruit growers began reporting reduced yields. Apples, cherries, berries, and melons all showed signs of weakened pollination. Hive rental prices exploded. Before the crisis, a hive cost around $65 to rent. During the height of the emergency, the price jumped to $170. Many farms could no longer afford pollination at all. Export contracts collapsed because growers could not guarantee stable production. Economists compared the breakdown to the collapse of the Irish bee industry in the late 19th century after the Isle of Wight disease outbreak. That crisis destroyed regional pollination. The Australian crisis threatened an entire nation. Government spending passed $200 million, yet the collapse continued without slowing down. Every measure failed to stop the parasite. Every warning sign grew stronger. Farmers, scientists, and beekeepers all understood the truth that everyone feared. With eradication of failure and agriculture crumbling, Australia needed an entirely new strategy. Surprisingly, nature delivered the first breakthrough. How nature fought back. The situation appeared hopeless until researchers began noticing unexpected changes inside a small number of surviving colonies. These changes came from the bees themselves. Researchers explained that this happened because the colonies that survived the first wave of infection were forced to adapt. Varroa killed the weakest hives quickly, which left only the strongest colonies behind. These surviving colonies carried traits that helped them notice mites earlier and react faster. Over several generations, the bees in these colonies began showing stronger defensive behaviors. The pressure from the parasite forced the bees to develop responses that they had never shown on a wide scale in Australia before. The first signs of this natural resistance appeared when beekeepers reported unusual grooming behavior. Worker bees were seen biting and pulling mites off one another. This behavior is known as Varroa-sensitive hygiene. It had only been documented in a few special bee lines in other countries. The bees were not trained to do this. They developed the behavior on their own because bees that could remove mites had a higher chance of surviving. It became the first major indication that some colonies were fighting back. The next discovery was even more surprising. In certain hives, worker bees began removing infected larvae from sealed brood cells. Bees normally protect developing young, but these colonies took the opposite approach. They opened cells and pulled out the larvae before Varroa could reproduce inside them. This harsh method worked as a natural form of quarantine. By sacrificing a few young bees, the colony prevented a much larger outbreak. Scientists describe this behavior as a powerful survival response because it interrupted the reproductive cycle of the parasite. When researchers identified these resistant colonies, professional queen breeders became involved. Queen breeders are specialized beekeepers who raise queen bees for commercial use. They do this because the queen controls the genetics of the entire hive. If a queen is strong and resistant, her offspring will also carry those traits. Once scientists confirmed which colonies were surviving Varroa, breeders selected the queens from those hives. They placed these queens in controlled breeding environments where they could produce new daughter queens. Each daughter queen carried the same resistance traits as the original survivor colony. These new queens were then introduced into other hives across the country. This method allowed Australia to spread natural resistance quickly because every colony headed by a resistant queen created worker bees with stronger defenses. This approach followed the same principles used in past conservation efforts, where experts multiplied the strongest survivors to rebuild a threatened population. Nature also helped in another critical way. Australia has more than 1,700 species of native bees. These bees are different from honeybees. They do not form large hives and do not produce commercial honey. Most importantly, they are immune to Varroa. Farmers and ecologists encourage native bee populations by creating suitable nesting areas and planting flowers that native species preferred. This created a dual pollination system that helped prevent immediate agricultural collapse. Farmers also restored wildflower corridors around their land. These corridors created continuous feeding routes that improved bee nutrition. Better nutrition helped bees recover faster from stress and infection. Conservation groups had used similar strategies in Europe during the decline of bumblebees in the past. The same idea worked again in Australia. Australia also shifted to integrated pest management. This system focused on steady monitoring, careful treatment, and reducing stress on colonies. It replaced emergency destruction with a long-term plan. Nature showed its strength through survival behavior, genetic resilience, and ecological support. But nature alone is not enough. What happens next surprised the scientific world. The scientific counterattack. While nature gave Australia its first signs of hope, scientists knew that natural resistance alone could not stop Varroa. The parasite continued to spread through regions that did not have strong survivor colonies. This meant that Australia needed a second wave of defense. The response came from laboratories, research centers, and technology groups across the country. For the first time, science and agriculture combined their efforts in a direct and urgent attempt to stop a national collapse. The first major breakthrough came from the installation of smart hive sensors. These small devices were placed inside hives and recorded temperature, humidity, sound levels, and mite density. Healthy hives have steady conditions. Sick hives change temperature or produce different sounds. The sensors collected this data every few minutes and sent it to a central system. This allowed experts to see which hives were struggling before any visible signs appeared. Beekeepers who once depended on monthly inspections could now receive alerts in real time. This turned every hive into a continuous surveillance point. It meant that early outbreaks were detected before the colony reached the point of collapse. When an outbreak is detected, beekeepers take action immediately. They inspect the hive to confirm the presence of mites, remove heavily infested brood frames, and apply fast-acting mite treatments that target the parasite before it multiplies. If the hive shows severe infection, beekeepers isolate it so the mites cannot spread to nearby colonies. Early action keeps the parasite load low and prevents a full collapse. Artificial intelligence programs added another layer of protection. These systems analyzed the incoming data from thousands of hives. They were trained to recognize patterns that signaled stress or parasite activity. I could identify unusual movements or feeding behavior within hours. Beekeepers no longer waited until bees collapsed to act. They could respond as soon as the system flagged a problem. Genomics labs also played a major role. Scientists used nanopore sequencing to map the genes of bees that showed strong resistance. Nanopore sequencing is a method that reads DNA quickly and accurately. It allowed researchers to identify which genetic traits gave bees a higher chance of surviving varroa. This technology worked at a speed similar to the development process used during the creation of the COVID mRNA vaccines. The fast turnaround helped breeders expand resistant bee lines far faster than traditional methods allowed. CRISPR research pushed the progress even further. CRISPR is a tool that allows scientists to study genes by cutting and editing DNA in controlled ways. Researchers used CRISPR to locate the immune pathways that made certain bees more tolerant to varroa. This approach had been used in the past to help restore declining coral populations. In bees, it allowed scientists to understand which traits were essential for resistance. Breeding programs then focused on these traits to strengthen future generations. The country also launched a national mite tracking application. Every beekeeper could record mite levels on their phone. The data synced to a national database. This created a continent-wide early warning system. If mite levels rose in one region, everyone nearby received alerts. This allowed treatments to be timed correctly. Within months, Australia coordinated treatments across entire states. The system worked like a synchronized effort that blocked varroa surges before they spread. After 1 year of non-stop destruction, emergency experiments, genetic selection, and new technology, Australia reached a point that experts once believed was impossible. The unbelievable results. By mid-2024, hive losses dropped by 20%. The stability became most visible during the almond season. Almond pollination is one of the most demanding agricultural events in Australia. It requires more than 300,000 hives each year. During the early crisis, farmers feared that the almond industry would fail completely. Many growers believed they would have empty fields and broken contracts. Instead, the season finished with enough healthy colonies to pollinate the major orchards. Several farmers described the event as watching destruction freeze in place and suddenly shift in a better direction. For many of them, the recovery felt unreal because they had spent over a year preparing for the worst possible outcome. Another major surprise came from honeybee genetics. The strong survivor colonies that had shown early resistance began to spread across states. Queen breeders raised new queens from these strong lines and introduced them into hives in different regions. The new colonies produced worker bees with better grooming behavior and stronger immunity. Researchers feared that Australia would lose its unique honeybee genetics during the crisis. Instead, they found that the new generations had developed traits that made them more resilient than before. This improvement happened far faster than anyone expected. Urban beekeeping also produced unexpected results. Apiaries in Sydney and Melbourne reported some of the healthiest hives they had ever recorded. These hives had access to stable climates, diverse flowers, and constant monitoring. Many urban colonies showed strong growth in low mite levels. This development was shocking when compared to the scenes from 2022, where dead bees covered the entrances of collapsed hives. The new data showed a clear shift. Australia had moved from widespread collapse to a new and more controlled state. However, these improvements did not mean the danger had passed. Varroa continues to spread across new regions. The crisis did not end. It changed into a containment equilibrium. Scientists explained that this situation was similar to how humanity lives with influenza. The threat never disappears. It becomes a permanent part of the environment. As long as Varroa exists, colonies remain at risk. Experts warned about several dangers that could appear in the future. A stronger variant of the mite could emerge. Chemical treatments could lose their effectiveness as Varroa becomes resistant. Another parasite could follow the same path and create a second wave of destruction. Even native bees, which are currently immune, could face new threats if conditions shift. Australia no longer aims to eliminate Varroa completely. The new goal is simple survival. Thank you for staying with us to the end. Please subscribe to the channel for more informative videos.